Can these compete with Tesla and Figure? Today on AI News, several new humanoids were just revealed, so we're comparing their specs, hardware, and abilities, plus watch till the end to see where the AI boom is headed next. So first, let's start with the most important robot peripheral, a dexterous manipulator, and Proception AI just released their ProHand Gen 1, but with a twist. At its core, this ProHand is a human-scale, biomimetic, tendon-driven hand with 22 total degrees of freedom, and 18 of them are being actively actuated. And the architecture provides dexterity through a 2-degree of freedom wrist and an opposable thumb that's capable of 120-degree rotation. And in addition to these physical joints, the ProHand also includes an integrated wrist camera for visual tracking, and along with this visual data, the control system runs directly on board the hand with just a 10 millisecond response time. Moreover, the hardware maintains internal state awareness with proprioceptive sensing arrays, continuously processing real-time telemetry, including 50 Hz voltage, position, current, and temperature from every individual actuator, all fused with a forearm IMU for drift-corrected pose estimation. And all of it relies on a single USB 2.0 connection for plug-and-play integration, alongside a software stack that's built on Rust, C++, and Python, with the hand weighing just 2.7 kilograms or 6 pounds, while still exerting a massive 30 Newton per fingertip force. And while ProHand is solving dexterity, Apptronik is taking a new full-body approach with Apollo 2, featuring a modular base with either 2 legs or a wheeled configuration, plus custom patented actuators that deliver 90% plus energy efficiency and hot-swappable batteries, as well as a chest display so humans know its exact status. But tell us down below in the comments which hand you think is best, as RobotEra just released its Xhand 1 Pro, which weighs just 0.88 kilograms or about 2 pounds, with a fully actuated 21 degree of freedom quasi-direct drive architecture. In fact, by avoiding under-actuated designs, every joint is directly controlled. Furthermore, it features an independent actuator that's built directly into the lateral palm, improving its little finger opposition, which gives it a 135-degree finger spread. And on top of this, an enveloping grasp diameter exceeding 160 millimeters allows single-handed manipulation of larger objects like basketballs. And to conquer the sim-to-real gap in AI training, RobotEra dropped single joint backlash to under 0.25 millimeters and hit a repeat positioning accuracy of just 0.1 millimeters using a dual encoder system with a hybrid control algorithm. And on top of that, the hand can open and close more than 5 times per second to make split-second adjustments, which dramatically reduces the time it takes for the robot to learn new tasks by trial and error. But what's more is the hand's spatial awareness, because instead of an internal skin, it embeds 18 physical tactile sensors inside, with 5 on the fingertips, 10 on the finger pads, and 3 on the palm. And these allow the fingertips to capture true 3D force sensing at a 0.01 Newton resolution. And alongside this, it features a 10mm non-contact proximity sensor to optimize grasping right before making contact. And its joints are entirely backdrivable to absorb impacts, and they're validated through 200,000 load tests. Plus, integration is straightforward, with the hand featuring a 24-volt to 72-volt input. And on top of this, the software runs natively on Ubuntu with full C++, Python, and ROS 1 and 2 SDK support. But tell us in the comments if you think this is a better design, as Persona AI isn't building sleek humanoid robots, but instead robots that can actually use tools for the grittiest, toughest job sites on the planet, like shipyards, active construction zones, and heavy energy infrastructure. Instead of worrying about flawless aesthetics, Persona AI is borrowing design principles from aerospace and marine engineering for something even more rugged. So a huge part of what makes these humanoids practical is their modularity, meaning that if a part breaks, a technician can easily swap it out right there on the field without needing a specialized clean room. And to survive brutal elements like weld spatter, salt water, metallic dust, and intense UV rays, the robots are wrapped in a tough, flame-retardant textile skin that seals off all the sensitive internal tech. Plus, they also feature incredibly advanced balance control and custom engineered soles. On top of this, they even feature liquid-cooled actuators, thermal protection, and heavy-duty shielding to handle grueling tasks like grinding and welding. And instead of flashing screens, they use simple sound cues and responsive RGB lighting to let workers know exactly what they're doing. But there's another brand new robot from Vin Motion called the Motion V2, and this comes from Vietnam, standing at a height of 178 centimeters or about 5 feet 10 inches and weighing just 75 kilograms or about 165 pounds, with a payload capacity of 40 kilograms or about 88 pounds. And throughout its body, it features 31 proprietary smart motors. And when it comes to artificial intelligence, it has an onboard Qualcomm Dragonwing IQ-10. And to continue working 24 hours a day, it features dual hot-swappable batteries that work up to 4 hours per charge. And when it comes to full autonomy, Flexion just unveiled Reflect V1, an intelligence platform that lets humanoids complete complex, long-horizon tasks completely autonomously. Instead of relying on manual coding or human teleoperation, the stack combines a custom vision language model for mission-level planning with vision language action models and reinforcement learning across every layer. And this framework enables a robot to navigate multi-floor buildings, operate elevators, or use tools to open boxes. Plus, an upgraded low-level control module allows hardware to continuously adapt to uneven terrain, managing external physical disturbances and handling execution failures locally through its automated recovery behaviors. In fact, robots may be about to learn anything, as researchers introduce TaskNPoint to teach humanoids dynamic skills with a single human video demo per motion. And this paradigm addresses the data efficiency bottleneck by using a human coach to isolate the short, critical interaction window that determines success. Furthermore, the robot fills in the remaining trajectories through reinforcement learning and simulation. And in addition to its ballistic tasks like tennis forehands and soccer kicks, the model also trained a Unitree G1 to pick up boxes in under an hour on a single GPU, deploying directly to physical hardware without any per-task reward tuning. And finally, the next AI boom may involve crypto, as Ethereum just finalized ERC-8126 to create the global standard for AI security checks, which include wallet risk scoring. And here's a demo of the leading AI agent called Centry, which is already trading on virtuals. So tell us if you think Centry is the security AI agent for crypto, and what could this mean for the future valuation of the Centry token? Anyways, like and subscribe, and click this video here for more on the latest in AI and robotics news.